So now let us come to the next topic, normal distribution curve. This topic is in fact the base of understanding the inferential statistics. If I go around in your classroom and I check your body weight, the weight of all the students, don't you think will be maybe around 70 kgs? Some of you might be even 50 kgs, but some of you might be even 100 kgs. If I go and check your blood sugar levels, don't you think that maximum people will have blood glucose levels, fasting blood glucose of 90 to 100? Some of you might be hypoglycemic and some of you might be in super fed state. If I go and check about your height in the class, mostly people will be around maybe 165 centimeters or 170 centimeters. Some of you might be 155 also, somebody might be 180 centimeters also. So whatever I do, many of you are around the mean or the central point. This concept is called as a normal distribution curve. Whenever we take a large sample, the way people are distributed is usually a bell-shaped normal distribution curve. So this is what is a normal distribution curve. Let us talk about this normal distribution curve. MCQs on this. First MCQ. What are the features of a normal distribution curve? Normal distribution curve is also known as a Gaussian distribution curve. Gaussian distribution curve. It is a bilaterally symmetrical. Bell-shaped curve. The two ends of the curve never touch the baseline. Can you see that? I have never touched the baseline in the normal distribution curve. In the previous also, can you see that I have never touched the baseline? Right? So please remember the two ends will never touch the baseline. It's a bilaterally bell-shaped symmetrical curve, also called as the Gaussian distribution curve. This is what is a normal distribution curve. Next MCQ. Now your MCQ start. In a normal distribution curve, the center point will usually correspond to 0 standard deviations. The mean is equal to the median is equal to the mode. They all coincide. Where will they coincide? They all coincide at 0 standard deviation. So at the point 0 in a normal distribution curve, they will all coincide. So this point does not technically mean 0, but it is at 0 standard deviations. How much is the standard deviation in a normal distribution curve? The standard deviation is equal to 1 unit of standard deviation. That means the normal distribution curve is going to be red or jumped around in 1 standard deviation. What does it mean? That if this is the normal distribution curve, in this will be point number 0, that is 0 standard deviation. And then the standard deviation will be plus 1 SD, plus 2 SD and plus 3. So 1 standard deviation would be moving forward. Backside it will be minus 1 SD, minus 2 SD, minus 3 SD. Many times students get confused that why is it 0 when you are taking a blood pressure. You are saying that the blood pressure is 120. So 0 means it is at the 0 standard deviation. There is no deviation at the center point. That is what is a 0 standard deviation. And then you have plus 1 standard deviation. Then you have plus 2 standard deviation or another 1 standard deviation, another 1 standard deviation plus 3 standard deviation. So this is what it means that the mean, median, mode, they coincide where at point 0. The standard deviation is equal to 1. Also the area under curve. Area under the curve will be equal to 1. Area under curve equal to 1. So let's repeat it very fast with me. Please remember what are the features of the normal distribution curve. Normal distribution curve is also called as the Gaussian distribution curve. The mean, median, mode will always coincide. The tail will never touch the baseline. It's a bilaterally symmetrical curve. The standard deviation is equal to 1. The area under curve is equal to 1. That's all that you need to understand. What do you mean by area under curve? Please try to understand that this whole universe if we take the whole universe and put it into the distribution curve, we will find a normal distribution curve. So area under 1 means that technically we say that whatever population we are taking, the whole 100% of the population is being taken under this curve. So what does area under curve equal to 1 means? It means the whole population is taken. Just remember this. whole population is taken. That means the total population is accounted for. That is what it means, the area under curve 1. Why do we say that mean equal to 0? Because that means that the mean is at the 0 standard deviation. Did you get this? This is very important for us to understand that what is a normal distribution curve. If you have understood this, now let us move forward into understanding more into the normal distribution curve. Let us say I conduct a study and the study gives me a data of hemoglobin. Mean hemoglobin is 10 gram percent with a standard deviation of 2 gram percent. With plus minus 2 standard deviation, that is 2 gram of percent of standard deviation. So what does this 2 mean? It means the standard deviation. What does this mean? This means the mean. It's generally written as 10 plus minus 2. We don't write that the mean is 10 and the standard deviation is 2. It is just understood. So now can you draw a normal distribution curve for this? So yes, I can draw a normal distribution curve. The mean will be equal to 0 at the 0 standard deviation. But the mean will correspond to how much? Mean will correspond to 10. Okay, then plus 1 SD, plus 2 SD, plus 3 SD, minus 1 SD, minus 2 SD, minus 3 SD. So what should I write here at plus 1, plus 2 and plus 3, minus 1, minus 2 and minus 3? What should I write here at plus 1 SD? It will be 12. Why 12? Because 1 unit of standard deviation of the normal distribution curve is corresponding to 2 gram percent of the hemoglobin. Are you getting it? So don't make it as that sir asked 1 SD add, so it becomes as 11. That's a wrong answer. 11 won't be the answer over here. 1 SD, 1 standard deviation of the normal distribution curve is equal to 2 gram percent of the hemoglobin. So what will you write at 12 at plus 2 SD? That will be 14, plus 3 SD will be 16. Minus 1 SD will be 8, then 6, then 4. Are we comfortable with this? Let us say that the data comes up as maybe for the mean for the blood pressures is 120 plus minus 10. What are you going to write now? It will be 120, then 130, then 140, then 150. And then you just subtract it. That is 110, 100, and then you have 100. And then you have 90. Are we comfortable with this? So this is the data for BP, and the above one could be the data for hemoglobin. So that's how you draw a normal distribution curve. So now, if you have understood this, let us move ahead and let's talk a little bit more in detail about the normal distribution curve. You already know that this is the mean point, which corresponds to the 0. Then you have plus 1 SD, plus 2 SD, plus 3, minus 1, minus 2, minus 3. Let us say that the data, we'll take the previous example only, that the data for hemoglobin was given to us as 10 plus minus 2. So what do you want me to write at the center point? That is 10. So you have over here 12, then 14, then 16, and then 8, then 6, then 2, and then 4, sorry, then 4, right? So we are okay with this now. This is the data for hemoglobin. Now, there is assumption number 1. There are 2 points I will discuss with you. The first point I am discussing with you right now. The point number 1 which you need to remember for your exam. That's how I have been trained, and that's how I want to train you as well. Try understanding that between, I don't know how it happened. You can't ask me that how does it happen. That's why I'm telling you it's an assumption. So just take it for granted for right now. Very soon in the next couple of minutes or in the next module, you will understand that why did we take this assumption. It is seen that between minus 1 and plus 1 standard deviation, it is usually seen that 68% of the population will lie. Between minus 2 and plus 2 standard deviation, it is seen that 95% of the population lies. And between minus 3 and plus 3 standard deviation, it is seen that 99% of the population is lying. So you can't ask me why does it happen, but that's how, it's a fact that we have seen. So the assumption number 1 for you to remember is that between plus minus 1 SD, how much percentage of the population lies. Please remember it is 68%, approximately 68% of the population lies. Between plus minus 2 standard deviations, 95% of the population lies, and between plus minus 3 standard deviations, 99% of the population is going to lie. So if you have, let's say 100 people, so out of them 68% are going to lie between how much hemoglobin? Between 8 gram percent and 12 gram percent. 95% people will lie between hemoglobin of 6 and 14, and 99% population is going to lie between 4 and 16. So if you understand this, now let us try to play with this. Okay. So now if you want to play with this, Let us try to play with this using a small MCQ. Let us say that the question is the mean blood glucose in a study from India was found to be 90 plus minus 10 standard deviations. How much population is expected to fall between 80, 100, 70, 110 and so on and so forth. So if you just look at this, and if I draw a normal distribution curve over here, and if I see that this is the 0 point, so obviously what should I write at the 0 point? How much is the mean? It is 90. Plus 1 SD, plus 2 SD, plus 3 SD, and then you have the minus 1 SD, minus 2 SD, and then you have the minus 3 SD. So that will be minus 3, minus 2, minus 1, plus 1, plus 2, and plus 3 standard deviation. So now, how would you want me to fill this normal distribution curve? Over here at plus 1 SD, how much should I write? 90 plus 10, that is 100. And then you're gonna have 110, and then you will have 120. I hope I'm correct. On the back side, it is 80 and then 70 and then 60. Simple answer. So you have drawn a normal distribution curve using this data. What is the data you were given? 90 plus minus of 10. What it is it a blood glucose or a blood pressure or HB levels or anemia levels or whatever it is, that is separate story. But mind you that over here, what we have is a normal distribution curve, and that's how we are going to fill it. Now, the first question is that how much population is going to lie between 80 and 100. So what do you think? You already know that between 80 and 100, how much percent of the population will lie? It is 68%. Between 70 and 110, how much percent of the population? 95%. Between 60 and 120, how much percent of the population? 99. So how much percent of the population will lie between 80 and 100? 68. So answer is very much direct. That is 68% of the population will lie. Let us say there are 1,000 people. So out of 1,000 people, how many are going to lie between this? That is 680 population is going to lie between 80 and 100 mgdl of this blood glucose level. How many people will lie between 70 and 110? So that is again a very simple direct MCQ. Between 70 and 110, how much population will lie? Right? So between 70 and 110, you already know that 95% is going to lie. So 950 population will lie between 70 and 110, right? Next MCQ. How much population is going to lie between 70 and 100? So that's a kind of tricky MCQ. How much population is between 70 and 100? You know that between 80 and 100 is how much? That is 68%. So technically this question is asking you how much population is lie within this much only. If you know that, then you can add. So very simple to calculate, no brainer in this. You take the whole 95. So out of 95, you have 68. Right? So you are wanting to calculate this, right? So out of 95, you have 68. So you want to calculate this much. So 95 minus 68, 95 minus 68, that comes out to be 27. So out of 27, half is this side, half is on the other side. Half is on this pink color shaded area and half is on another yellow colored shaded area. So not this one, sorry, on this one. Why? Because it's a bilaterally symmetrical curve. So 27, you need to decrease it, you need to divide it by 2, that is half. So that means 13.5 is what is there in this area. So if somebody is asking you how much population is going to lie between 70 and 100, what will be your answer? It will be 680 population plus 13.5% or 68% plus 13.5% will lie between that much area. Are we okay with that? That's just kind of brain twisters you get. That's all. Next is how much population is going to be more than 70. That's easy. How much population will be more than 70? What do you think you're going to ask? You're going to answer. Please try to understand how much population will be less than 70. So you already know that 70 is what? 2 standard deviation. So that means out of total 100, 95 will be between minus 2 and plus 2. Okay. Out of total 100, 95 is between minus 2 and plus 2. So how much is left out, beta? It is 5%. 95 gone out of 100. 90, you remember area under curve is 100%. So out of 100, 95 are gone. So 5% is left out. Half will be this area, half will be this area. right? So half will be less than minus 2 standard deviation, half will be more than 2 standard deviation, that means 5%, that is 2.5 will be less than 70 and 2.5 will be more than 110 mgdl. So if this question is asking more than 70, so that means 2.5% is less than 70, so how many will be more? Common sense, that is 97.5%. Are we okay with this? Next MCQ, let's have another one. Less than 100, how many people are there? Less than 100, what is 100? 100 is the 2 standard deviation. So less than 100, how many are more than 100? Same, 16%. So how many will be less than 100? Now I think you must be getting it. It is same answer, 84%. Are we okay with this? Because less than 100 he is asked. If the question was asking more than 100, then what you would have marked? 16%. Anyways, let's go to the next MCQ. Let us talk about less than 60. How much population is there? So total is 100. 60 is at what level? 60 is at minus 3 SD. So total is 100. You know that minus plus 3 standard deviation is 99. So total is 100. 99 gone. So how much is left out? 1%. Half will be this side, half will be that side. Are we getting it? It's super easy. So less than 60 will be how much? It will be 0.5% population is going to lie less than 60 mgdl. Next MCQ. How much will be less than 120? Same answer, beta. It's nothing to get scared of. What is 130, 120 at what point? It is at plus 3 standard deviation. So total is 100. Plus 3 is at 99%. So total is 99, right? So out of 100, 99 are gone. 1% is left out. Half this side, half this side. So how much population is more than 120? More than 120 will be 0.5. How much is less than 120? Less than 120 will be 99.5% population. Are we getting it? So in this way, there could be many more permutation combination. I have just tried to summarize the data for you and try to present to you in a kind of a simplified language so that you just open up your mind and you can answer it. Right? So let's see if you have actually understood and let's try to solve one of the MCQs. Just look at the MCQ. The mean blood glucose from 5929 ANC females in a state of Maharashtra was found to be 130 plus minus 5 mgdl. So the blood glucose was found to be 130 for gestational diabetes mellitus, probably they are checking. The cutoff for diagnosing GDM was found to be, was kept at higher than 140. How many pregnant females are expected to be GDM diagnosed? So I just give you maybe 40 seconds you can take for solving this type of MCQ. It's particularly very easy direct MCQ. All those who have done it, very nice. Let's try to do it. Let us say that this is the normal distribution curve. I don't want to draw that curve, okay? So I'm just drawing a single line now. So I think slowly we are advancing in understanding it. So if you draw just a single line, so what should be kept at the center point? How much is the mean? That is 130. This is the mean, right? The mean is 130. So plus minus 5 mg. So plus 1, plus 2, plus 3, minus 1, minus 2 and minus 3. So plus 1 standard deviation would be 135, then 140, then 145. Are we okay? Minus would be 125, then 120 and 150. I hope this is correct. Okay. So the 130 is the, what is the mean? Okay. So now the MCQ says the cutoff for diagnosing GDM, was kept at higher than 140. So beyond this, people were called as diabetic GDM. How many pregnant females are probably GDM diagnosed? So technically this question is saying how many people are more than 140. So you already did that couple of times. 140 stands at what standard deviation, beta? It stands at plus 2 standard deviation. How much is population between minus 2 and plus 2? 95. So 95% out of 95%, out of 100, 95% gone. So how much is remaining? 5%. 2.5 will be less than 120. 2.5 will be more than 140. So that means what is the total number? It will be 2.5% will be more than 140. 2.5% of 5929 patients. So don't start over here by multiplying 5929 into 2.5 and this. Don't do that. It's not required. Just look at the options at least. So if you just look at the options, you can round it off to 6,000, right? So if you round it off to 6,000, 6,000 multiplied by 2.5. So how much will it be? 25, 2.5 times 6. So 6 2s are 12, 12 and another half of it, 0.5 of it. So 12 plus 3. 3 is half of 6, right? So 12, 3, 15, 15, 150. 150 females will be diagnosed with GTM. So what is the answer over here? We would like to mark option number C. That is 150, which falls safely into the zone of 100 to 200. You're very good to mark. In case you have already done that, very nice. So this is the concept of finalizing that what a population lies where. So what take-home message that you need to remember is that 1 standard deviation is 68, 2 standard deviation is 95, 3 standard deviation is 99% population. That is approximate always. So mind you, please say with me 1 SD 68, 2 SD 95, 3 SD is 99. That is your assumption number 1, point number 1 for you to remember. Point number 2, assumption number 2 that you need to remember. Let us say I take this normal distribution curve, and in this curve, let us say take that same example that the mean hemoglobin was 10 plus minus 2. So in the center, I'm going to write 10, then 12, then 14, then 16, then 8, then 6, and 4. So that's for the hemoglobin. Are we okay with this till now? So very good. So you all know that 1 SD, 2 SD, 3 SD. So this is what is 1 standard deviation. Then you have the 2 standard deviation. Then you have the plus minus 3 standard deviation. Right? Plus minus 1, 2 and 3 standard deviation. That's fine. Now, assumption number 2. Again, you can't stand up and ask me, why are you saying so? That's what we have observed. In slowly time to come, you will understand automatically that why did I say so. But for right now, it must be assumption for you. Assume that this happens. It is seen that whatever is done by 95% of the population, mark the words, whatever is done by 95% of the population, that is always taken as the zone of normalcy. That is always taken as the zone of normalcy, or it is a normal zone. What do I mean by this? It simply means that if the 95% confidence is ranging from 6 to 14, it means that if I come from this area only and my hemoglobin is, let us say 15, will I fall in the normal zone or in the abnormal zone? I will fall within the normal or outside, it is outside. So this person is in the abnormal zone. So that means this person's BP or this HB or whatever you are testing is in the abnormal zone. Right? So please remember that the zone of normalcy ranges from what to what? That is from -2 to +2. If you understand the zone of normalcy, now let me take you to understanding what is a Z-score. Z-score is also called as a standard deviate. Z-score tells you what? It tells you the location of a person, location of a value, not person, location of a value in terms of the standard deviations. It tells you the location of a value in terms of standard deviations. It is calculated by the formula observed value minus the expected value divided by the standard deviation. Z value or the standard deviate is calculated by observed minus expected divided by standard deviation. So Z-score tells you the location of a value in terms of ST. So now let us go back to our MCQ and to our same normal distribution curve and let us see the utility of this Z-score. If you talk about the Z-score, let us say I belong to the same population. My observed value for the hemoglobin is 15. Okay, calculate the Z-score. Z-score is given by the formula observed minus expected over standard deviation. In this case, what is the observed value? My value, that is 15, minus expected. What will be the expected value? Beta, please remember that the expected value in all the situations will always be the mean value. That is what we are expecting. So the expected value is the mean value. What is the mean in this particular example that we have taken? That is, mean is HB, 10 plus minus 2. So minus 10 divided by standard deviation. How much standard deviation points they have given? They have given 2. So what is the answer? That is 5 by 2. That is 2.5 will be the standard deviate. So what does this 2.5 means? It means that whoever this person is lying 1, 2.5 standard deviations away from the mean. Are you understanding what is the standard deviate? Standard deviate tells you the location of a person in terms of standard deviation. If it comes as 2.5, it means that this person is standing 2.5 SDs away from mean. In simple, very simple words, it means 2.5 is the SD at this particular value. That means 15 value is equal to 2.5 standard deviations. Simple word, na? So that means Z will tell you the value of a person in whatever sense. Let us say I belong to the same population and my HB comes out to be 9. Calculate the standard deviate. So that means you are going to calculate 9 minus 10. That is, what is the expected? Observed is 9 divided by the standard deviation, that is 2. So that will be minus 1 divided by 2. That will be minus 0.5. So where am I? I am located half standard deviations away from the mean. Minus, towards the minus sign, right? Towards the backside. So this basically tells you the location of a person on a normal distribution curve. Now, very important understanding. That is what the AIIMS people had asked you. What is the use of this Z-score? What is the cutoff for this Z-score? The cutoff for normalcy of the Z-score will be how much? When will you say that this value beyond which is called as abnormal value? The cutoff for Z-scores will be plus minus 2 SDs. Are we okay with this? The cutoff for Z-score will be actually plus minus 2 SD. Why plus minus 2 SD? Because that is what is the zone of normalcy. So that means if my value comes out to be 14, it will exactly lie on the 2 standard deviations. If it is 15, it is more than 2. That means Z more than 2.5 or more than 2 is what? Z more than 2 is what? That is an abnormal Z-score. If the Z is less than 2, that means what? The value is lying within the normal zone. So what is the cutoff for Z-score? Please remember, it is plus minus 2 standard deviations. One small point over here. The point which I want to discuss with you over here is that, do you know that 1 SD corresponds to how much SD? 1 SD corresponds to 68, 2 SD will correspond to 95, 3 SD will correspond to 99% of the population. That's just what you had learned. But I'm sorry to say that this is incorrect. It is not technically correct. What is technically correct is 1 SD will correspond to 68.26% of the population, 95.45 and 99.73. I don't want to bore you with these numbers, but a point to be noted is, come again, what did I say is the zone of normalcy? What did I teach you that the second assumption is? The second assumption is not plus minus 2 standard deviation within this is normal. No. I told you that whatever 95% of the population will do, that will be taken as the normal zone, right? So that means that 95.45 is 2 standard deviation. So how much is 95? Technically, 95.45 is 2 standard deviation. So how much will be 95? 95% of the population technically corresponds to 1.96 SD. And that is what you need to remember for your exam. That means in AIIMS exam, the MCQ was not that what is the cutoff for Z-score and everybody answering that the cutoff for Z-score is 2 standard deviation. Wrong. In the option, they will give you that what is the cutoff for the Z-score. Options are plus minus 1 standard deviation, plus minus 2 standard deviation, plus minus 1.96 standard deviation and plus minus 2.84 standard deviation. What do you want to mark? If you are reasonable enough, you're going to mark 1.96 SD because that's a technically correct answer. However, if this is not there in the option, you will be marking plus minus 2 standard deviation, which is of course one of the gross things that we do. So at no point I want you to remember this. This is not at all required for your exam. It's not at all required for your exam. It is just for me to make that concept and to prove you that yes, 1.96 is there some number which exists and 95% is equal to 1.96 SD. Please remember the Z score will range from the zone of normalcy will be plus minus 1.96 SD. Technically saying, all said and done, for all the numericals also, we always take plus minus 2 standard deviation. So with that, you have finished the understanding on normal distribution curve, about the standard deviate and the zone of normalcies.